Okay, so we're going to have a binary source X. There's going to be a sequence of these binary elements, all up to xn, all by ID. But, so we assume that they're IID, but we also are aware that we do not know P of x. So, in this case, this is the practical scenario. So we're often given sources over given alphabets where we don't know the probability distribution over the source letters. So, everything that we know how to do so far, which is to do the Huffman procedure, or the Shannon-Fano-Elias code, or the arithmetic code, all of these techniques require us to know P of x. So, in practice, what do you do if you don't know P of x? That's the basic idea behind universal coding. So, a universal source code is one that approaches entropy in spite of the fact that you don't necessarily know the distribution in advance. So, let's have an example. Let's let n equals 5. So in other words, I have 5 binary source letters. Doesn't matter what they are, let's just represent them by symbols like that. So, one technique would be count the number of ones in x1, x2, x3, x4, x5. And then for each number of ones, use a different source code. So, basically the idea with this different source code would be one that enumerates all possibilities with, so count the number of ones in x1 to x5, let's call that k. For each value of k, use a different source code which enumerates all the possibilities with k ones. So this makes sense. Basically what I'm going to do, knowing the number of k is approximately the same as knowing the probability. For instance, if I had, if x is not 5 but a million instead, and I had approximately 200,000 ones, we could assume that the probability that x is 1 is somewhere in the vicinity of 0.2. So if I know k, that's in some sense similar to estimating the probability. Then what I'm going to do is, once I know k, I'm going to encode that. I'm basically going to make a list. I'll show an example of this, but I'm going to make a list of all the possibilities that have that number of ones, and find the index of the sequence I have on that list and transmit that index. I'll show an example in a second. But the basic idea would be that we send k followed by the index followed by the code word from code k. So each number of ones has its own source code. So basically what I'm going to do is I'm going to say I have k ones. So then the receiver knows, okay, there's k ones, so therefore this is in source code corresponding to that number of ones. And then I'm going to transmit the code word corresponding to that number. So we have basically two things to transmit. So the first thing to transmit, so the code word, consists of two parts. In this part we transmit k. And in this part, we transmit the code word of the kth code. So if I have k1s, how many possible ways, in my example, if n is 5, how many possible numbers of 1s can I have? So I can have 0 1s, I can have 1, a single 1, 0 1s, that's the all 0 sequence. A single 1, that's a single 1 somewhere in here, I can have 2, I can have 3, 4, or 5. In the case of 5, then all of these guys are 1. So how many possibilities do I have? I have 6, which is n plus 1. 1, 2, 3, 4, 5, 6. So this is some integer from 1 to n plus 1. Or excuse me, it's some integer with n plus 1 possibilities. How many bits do I need to express n plus 1 possibilities? Ceiling log n plus 1. Okay, now what I'm going to do is, knowing k, I'm going to assign, basically I'm going to assign a list, enumerating all of the possible code words and assigning them all an index. So by enumerating all the possible code words, I mean basically writing them down. So for instance, k equals 0, there's only one possible code word. Like that. In fact, because there's only one possible code word, I don't even need to assign it an index. K equals 1. What are the possible code words? I have 1 in the x5 position, 1 in the x4 position, 1 in the x3 position, the x2 position, or the x1 position. Those are my 5 possible, those are my 5 possible source sequences with k equals 1. So there are 1, 2, 3, 4, 5 of them. So the number of bits that I need to represent 5 possibilities is 3. So we can just assign these to 0, 0, 1, excuse me, 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0. So this is the source sequence, this is the code word. K equals 2. What I can do is I can say 0, 0, 0, 1, 1, 0, 0, 1, 0, 1, 0, 1, 0, 0, 1, 1, 0, 0, 0, 1, 0, 0, 1, 1, 0, so on and so on and so on. There's lots and lots of possibilities. And then assign each of them a unique index like this. Basically starting at the top, it's 0, 1, 2, 3, 4, etc. Now the question is, how many possibilities are there here? In this list, for k equals 1. There's 5. But more generally, that's right. So that's 5 choose 1. Because I have 5 digits and I have a single 1 and I want to know where to put it, there are 5 choose 1 possibilities where that can go. Over here there's 5 choose 2. So generally, this term is log n plus 1, and this term is ceiling log n choose k.